This is the r12 vector, r2 vector minus r1 vector. This was a vector. Now we are going to calculate its magnitude. What you will put? You will put the modular sign from here to here. See, this is r12 vector is r2 vector minus r1 vector. So what is its magnitude? Magnitude of r12 vector is the modulus of this, modulus of this also. Now you are going to find the r12 cap. R12 cap. You know that a unit vector is equal to a vector divided by its magnitude. What is r12 cap? R12 cap is r2 vector minus r1 vector divided by its magnitude. Okay, now make it as equation number 2 and this as equation number 1. Put 2 in 1. If we will put this in this equation, what will come? F21 1 by 4 pi epsilon naught q1 by q2. What you are going to place for r12 vector? Modulus square, that is r2 minus r1 modulus square. So what you are going to place? R2 minus r1 modulus square into r12 cap. What is r12 cap? R2 minus r1 vector upon modulus of r2 minus r1 vector. You are going to put it here. Now solve this. 1 by 4 pi epsilon naught q1 q2 r2 vector minus r1 vector divided by, this is r2 minus r1 modulus square and this is r2 minus r1 modulus. So when you will multiply them, their powers will be added. So it will be r2 minus r1 vector modulus q. Similar, this was the force on q2 due to q1. Now you are going to find the force on q1 due to q2. What will come? F12 vector is equal to 1 by 4 pi epsilon naught. Same, q1 q2. Now here it was r2 minus r1. Remember, this is 2 1. So it will r2 2 1 2 1. If it is 1 2, it will 1 2 1 2. Rest will remain same. Now see them clearly. F21 and F22. What is the difference? They are equal and opposite. Yes. So F12 is equal to minus F21 vector. That is, forcing the two charges are the forces of action and reaction. They follow the Newton's third law. Now we are going to do the numericals based on the Coulomb's law. Suppose it is given to you, you have a 2-point charges. You have 2-point charges q1 and q2, each of magnitude 1 coulomb. Let they are separated by a distance of 1 meter. Let F is the force between the two charges q1 and q2. Let it be 9 into 10 raised to power 9 Newton. If these two charges with the distance 1 meter having a force of 9 into 10 raised to power 9 Newton between them, they are immersed in water. With the same distance, you are not going to change the distance between what was the distance earlier? It was 1 meter. You are not going to change that distance. Now what is the new force? If K for water is given to you, that is 80. Dielectric constant of water is given to you 80. We did this formula. What was the formula? Dielectric constant or relative permittivity. The another name of dielectric constant is relative permittivity. It is the force between the two charges in air to the force between the two charges in another medium. Now what is another medium? It is water. So Fa by Fm is Fa by Fw, because now the medium is water. So what is Fm? Fa by K. Fa by K. What is the Fa? The force between the two charges when they were in air. It was 9 into 10 raised to power 9 Newton divided by K, that is 80 given to you. So what is the new force? 1.12 into 10 raised to power 8 Newton. Now next is, suppose you have 4 identical metallic spheres that can be treated as a point charges. Now suppose you have 4 metallic spheres. Sphere A, B, C and D. They are considered as a point charges. Now suppose on what is given to you, sphere A and B have charges QA and QB. How much is the charge on A? That is QA. And how much is the charge on B? That is QB. Now sphere A is touched with uncharged. This is an uncharged sphere C. You brought this in the contact of uncharged. You brought sphere A, which is having a charge QA, in contact with C sphere. Now in the question it is given to you, sphere B is brought in the contact with another uncharged sphere D. The separation between A and B. Now earlier the separation between these two charges is R. Now A is brought in contact with C, B is brought in contact with D. Whatever charge will now come on A and B, now the distance between them is reduced to be half. Suppose in दोनों के बीच में distance, what you have done, you have reduced to half. Find the new force in terms of the previous force. Now what is given to you? A and sphere B. Sphere A and sphere B. Sphere A is carrying a charge QA and sphere B is carrying a charge QB. Now they are separated by a distance R. It is given to you. You know that when the two charges are separated by some distance, Coulomb force act on it. What is the Coulomb force? K, F is equal to K. K is 1 upon 4 pi epsilon naught, because system of unit is not given to you. So you are not sure whether you are going to take it K as a 1 or 1 upon 4 pi epsilon naught. So you will simply put it as a K. F is equal to K, Q1 that is QA into Q2 that is QB upon distance square. Now what you have done, what is given in the question, you brought A in contact with C. Now C पे there was no charge. What was the charge on A? ये आपके पास, suppose this pen is having a charge 2 coulomb. This is my finger, it is not having any charge. When you brought my finger in contact with pen, this 2 coulomb charge will start transferring from pen to how much? Pen to where? Pen to my finger. Till the charges on the two bodies will become equal. We have done that if the two bodies are at different temperatures. You brought them in contact, the heat will keep on flowing from one body to another body unless their temperature becomes equal. Same here. This is a charged body, this is an uncharged body. When you brought the uncharged body, suppose this is an uncharged body, this is a charge. When you brought an charged body in contact with uncharged body, the charge from a charged body will keep transferring to uncharged body unless the charge on the two becomes equal. Up now, A is brought in contact with C. A is uncharged, A is charged and C is uncharged. When you brought in contact with each other, the equal charge will distribute on them. That means QA will distribute on both these two charges equally. So what will that? That is QA by 2 and QA by 2. Similarly, what was given in the question? It is given that B is brought in the contact with D. B was having the charge QB. Now when you brought them into the contact with D, equal charge will be distributed on both. So this was QB by 2, QB by 2. Now what is the net charge on A and B? The charge on A is QA by 2 and charge on B is QB by 2. And it is given they are placed at a distance R upon 2. Now it is given in the question they are placed at a distance R upon 2. Now find the new force. Let the new force between these two charges as per the Coulomb's law is F dash is equal to K. What was the new Coulomb's law? F is equal to K Q1 Q2 by R square. K, what is the first charge? QA by 2. What is the second charge? QB by 2 divided by distance square. What is the distance? R by 2 ka whole square. When you will solve them, K, QA into QB. This is 2 into 2, 4. R square by 4. 4 will be cancelled out. So what is this come? This is again the same force. So the new force and the previous force is same. That is force remains same. There is no change in the force. Thank you.